factoring is basically the opposite of the distributive property. So instead of multiplying everything through, you're going to divide similar pieces out of each term that you're talking about. So you're going to think about the greatest common factor, or the GCF, of all of the terms. The GCF is the prime factorization of each monomial. Then you're going to multiply their common factors together. So for example 1, if you look, we have 18 and 42. 18's prime factorization, if we break it down, these are our factor trees. 18 is divisible by 6. 6 times 3 is going to give me 18. 6 can still break down further because it can be more prime, and it breaks down or divides out into 2 and 3. So my factors for 18 are 2 times 3 times 3, because 2 times 3 is going to give me 6, and then 6 times 3 will give me 18. If I look at 42, I know that it's divisible by 6, which is going to give me 6 and 7. 6 is further divisible by 2 and 3, so your prime factorization for 42 is going to be 2 times 3 times 7. Once you have those prime factorizations all figured out, your greatest common factor is what they have in common. So as you can see, both the 18 and the 42 have a 2, and they also have a single 3. So your greatest common factor is going to be multiplying those two together, 2 times 3, which is going to give you a value of 6. If you look at example 2, I have 9k squared and 6k. 9 divides by 3, and you have 3 left over. 3's are prime numbers, so they can't get broken down or divided any further. And I still have my 2k's. So I have 3 times 3 times k because I have this k squared. If I'm looking at 6k, again, 6 is divisible by 3, and when you divide it by 3, you have 2 left. 3 and 2 are both prime numbers, so they can't be divisible any further. So your prime factorization of 6k is going to be 2 times 3 times 6. It's always important to write them least to greatest because it will be easier for you to see what they have in common. So as you can see, 9k doesn't have a 2, so it has a 3, and so does the 6k. They also have a single k that they share. So when I multiply my 3 and my k together, you end up with 3k as your greatest common factor. Remember, if there's no sign in between, it's understood to be a multiplication. For example 3, I have 10f squared, I'm comparing it to 8f squared, and 16f to the 4th. So we're comparing all 3 of these terms because there's not always going to be 2. So 10 is divisible by 5, and 5 times 2 is going to give me 10. 5 and 2 are both prime numbers. Therefore, I should have switched those. It should be 2 times 5 times f times f. Now we move on to the 8f squared. Again, you're going to have 2 f's because of that f squared. 8 is divisible by 4. 4 times 2 is going to give me my 8. 4 can be broken down further because it's not prime, so it's also divisible by 2, and 2 times 2 is going to give me that 4. So I have 1, 2, 3 2's, 1, 2, 3 2's that I'm multiplying together, and my 2 f's. And if we move on to 16, we know that 16 is 4 times 4, and both 4's, as we just worked out, are broken down into 2 groups of 2's. So I have 1, 2, 3, 4 2's, 1, 2, 3, 4 2's, and 4 f's that I'm multiplying together. Now it's comparing all 3 of these pieces. So I have 1, 2 here, 1, 2 there, and 1, 2 in that one. None of the others have a 5, so that's not in common. I have 1 f, 1 f, 1 f, a second f, a second f, a second f. So I have 1, 2, and 2 f's that are in common. When I multiply all of these pieces together, I get 2f squared. In the last example, if I have 8x squared y cubed z, and I'm comparing it to 12x to the fourth yz squared. So my 8x squared y to the third z, 8 we know breaks down into 2 and 4 breaks further into 2 and 2. So I have 3 2's, 1, 2, 3. I have 2 x's, 3 y's, and 1 z. If I do the same thing with my 12x to the fourth, I'm going to write it down here, kind of shove it in there. So 12x to the fourth yz squared. 12 is going to break down to 6 and 2, and 6 goes to 3 and 2. So I have 2 2's, a 3, I have 4 x's, a y, and 2 z's. And now when I'm comparing what they have in common, I have 1 2 here, 1 2 there, a second 2, a second 2. I don't have a third 2. I don't have a 3. I have 1x here, 1x, a second x, 1y, 1y. I don't have any more y's. 1z, 1z. I don't have anything else up here. So altogether, I have 2 times 2 times x times x times y times z. So my greatest common factor for this problem is going to be 4x squared y z.